Section 3.6 is an introduction to functions. And first we start with a relation, which is just a set of ordered pairs, and it can be represented with an ordered pair, a map, a graph, or an equation. The next concept we talk about is our domain and range, and if you take a minute to read this definition, pause it and read. Then after you've done that, we're going to determine the domain and range of each of the following functions for these three problems. The domain for number 1 is all of our x values, so that's going to be 2. I don't have to do 2 again because I already have it, 0 and 3. The range is going to be all my y values, or the second value, and that's going to be 3, 4, -1, and I don't have to repeat the -1 because I've already have it accounted for. In number 2, the domain, if I was to name these x and y, the domain is going to be the first values, which are -2 and 0. The range is going to be my second set of values, second coordinates, which is your y values, 3, 4, and 5. In problem number 3, my domain, first of all, list all my x values. So I have 1, 2, and -5. My range, I'm going to list 2, -2, and 0. Domain and range is a very basic concept, so we're going to move on and look at function. A function is a relation in which every x value corresponds to exactly one y value. When we're determining functions, basically we want to make sure that the domain is not repeated. So on number 1, we're going to check to see if our domain is repeated. We'll look at our domain, -2, 2, -3, 9. The domain did not repeat, so I would say yes, this is a function. On number 2, my domain of 4, it's paired with 2, and it's also paired with 6, therefore it's not mapped to exactly one y value. That means it's not a function, so no. Number 3 says, if I have that equation and I made an xy table, and I chose, since it's solved for y, if I chose some values for x, let's just do -2, 0, and +2. If I was to substitute -2 in and solve, that's -4. Next time, if I was to substitute 0 in, I get 0. And if I substitute +2 in, I will get 4 by picking random points. And I'll assess these ordered pairs and say, yes, this is a function. And number 4, if I was to make an xy table, because this is solved for x, I'm going to pick values for y. So let's just pick some similar ones, -2, 0, and +2, and put those in place of y. If I put -2 in there, -2 squared is +4. If I put 0 in there, 0 squared is 0. And then this time if I put +2 and squared, I get 4. But if you would see, if you look now and you notice that this x value, our domain repeats, that means no, this is not a function. Next, we're going to talk about function notation. This is an original equation which we're used to seeing, and today we're going to talk about function notation, which is just f of x equals 2x plus 3. So basically, f of x, y equals f of x. It's just a different notation. To find each value, they can give us different levels. Sometimes different letters are variables. Sometimes they'll say g of x, sometimes h of x, f of x. It all means the same idea and the same concept. It says take this function, and everywhere x is at, you want to substitute a 1. See that? Everywhere x is at, you want to substitute a 1. So basically, what we're going to do on all of these is I take my function, and everywhere x is at, I'm going to substitute a 1. from right there, so I put a 1. Bring the rest of the equation down the same, so you get 3 minus 2 is 1. So I would say the g of 1 equals 1. The g of 1 equals 1. And number 2 says if f of x equals that function, then find f at negative 2. That means everywhere x is at, I want to put a negative 2. Bring down everything else, exactly the same. And all I did was substitute negative 2 in place of all of the x's. Now I'm going to solve. Order of operations says do exponents first. That's going to be positive 4. Negative times a negative is a positive 6. 4 times 7 is 28. Plus 6 plus 1 is 35. So I can say the f of negative 2 equals 35. That's basically saying f of x equals y. When I plug negative 2, when I read this, when I plug negative 2 in for x, my y came out to be 35. So that's another way to look at function notation. So this is our answer to problem number 2. The last thing we're going to look at is vertical line test, which this is very basic concept. If I have this, then I'm going to draw a vertical line, and it cannot touch more than one time. So when I draw a vertical line here, it touches 2 times. That means no, this is not a function. If I draw a vertical line there, it's 1, 1, 1. So this one passes and says yes, this is a function. No, it touches more than one point. When I draw a vertical line, that means not a function. No, this is not a function. If I were to draw, if I have one that looks like this, and I try vertical line test on it, if I drew a vertical line, it touches this point, but an open circle means it doesn't touch, so therefore it's only touching in one spot. This is yes. And then if I had one that was like this, a piecewise function, and I did vertical line test to it, that one would be no because it touches here and here because they're closed circles, so that's no, it's not a function. So vertical line test is a very easy concept to determine whether a graph is a function.